All right, let's continue solving equations with radicals. Now we've solved equations with one radical and one x. We've solved equations with multiple x's and radicals. Now what happens if we have equations with two different radicals and maybe two x's? We're going to follow a few steps. The first thing we're going to do is isolate one of the radicals, right? That's our step one in all of our radical equations, is to try to get the radical by itself. The problem is if we have two different radicals, we have to try to get at least one of those radicals by itself. You might not be able to get both, but maybe get one. Then we can use the principle of power, where we can square or cube or raise to the fourth power to get rid of the radical. If a radical remains, then we have to perform that step again to get rid of all the radicals eventually. We're going to solve the equation, and then remember, we always want to make sure that we check our solutions in our original equation to make sure that they work. Let's look at example 4. It says to solve, we have the square root of 2x minus 5 equal to 1 plus the square root of x minus 3. You notice that we have two radicals and two x's. If you look on the left side, that radical, though, is all by itself on that side. So that's what we want to happen. We want to get at least one of the radicals by itself. From there, what we want to do is we want to square both sides. When I square the left side, I want to also make sure that I square the whole entire right side. The square and the square root on the left side should cancel each other out. But remember, on that right side, I have 1 plus the square root of x minus 3. That's two terms, and I want to square it. That really means I have a 1 plus the square root of x minus 3 times another 1 plus square root of x minus 3. I have to make sure that I FOIL that craziness. You ready? When I do that, I have 1 times 1, which is 1. I have 1 times the square root of x minus 3, which is just the square root of x minus 3. I have the square root of x minus 3 times 1, which is just another square root of x minus 3. And now here's the hard part. I have the square root of x minus 3 times the square root of x minus 3, which would really mean I have the square root of x minus 3 squared. I have two of them, right? Well, don't the square and the square root on that one also cancel? So then I'm actually just left with an x minus 3. So if you look on that right side, I have a couple of different like terms. I have a regular 1 and a regular negative 3. Those are just regular numbers, no parentheses, no radicals attached to it. I should be able to combine those. And then if you also look, I have a 1 rad x minus 3 and another 1 rad x minus 3 that are also like terms that I can combine. I can really combine those into 2 rad x minus 3s. I have the 2 minus 3, which is my negative 2, and then I have the positive x that's still left. So now I have a 2 times the square root of x minus 3, a positive x, and a minus 2 on that right side. On the left side, I have a 2x minus 5. Okay, you notice that I still have a radical left in my problem, and we're still trying to get those radicals all by itself. So what we want to do is try to get that radical by itself still. You notice that there's an x and a negative 2 that I want to get rid of. So let's go ahead and subtract x to both sides and add 2 to both sides so I can try to get that radical on that side by itself. When I do that, I end up getting an x minus 3 on the left side. On the right side, I have a 2 times the square root of x minus 3. Now from here, you might be thinking of getting rid of that 2, which is a possibility. You could divide both sides by 2 if you'd like to. Now, you're going to end up getting fractions on that left side, so you might want to avoid that. Another trick, what you can do, now that our radical is pretty much by itself, it just has a coefficient. What I mean by that is there's nothing added or subtracted behind that radical that I have to get rid of. If the radical is by itself and it only has a coefficient, a number right in front, what I can do now is use my principles of power. I can square both sides. Now, if I square this side, I have to make sure I square the other side. Now be careful. When you're squaring this side, what you really have is 2 of them, right? You have 2 times the square root of x minus 3 times another 2 times the square root of x minus 3. You notice that I have 2 times 2, which is really 4. And then you have a square root of x minus 3 times the square root of x minus 3. Which remember, when we have 2 of the same thing underneath the radical, there's a squared in there, and the square root cancel. So what I really have on that side is a 4 times an x minus 3. Remember, 2 times 2, or 2 squared is 4. And then the square root of x minus 3 squared, the square and the square root go away, so then I'm just left with an x minus 3. Okay, look at the left side. The left side was an x minus 3 squared. Remember, that means I have two of those, an x minus 3 times another x minus 3. Okay, now you notice now that I have no more radical, which is perfect. That's what we were trying to get to. We were trying to get all of our radicals by itself so that we can get rid of them eventually. Now let's go ahead and FOIL and distribute. When I FOIL the left side and combine like terms, I ended up getting an x squared minus 6x plus 9. When I distribute the right side, I ended up with a 4x minus 12. It looks like I have x squareds and x's, a quadratic, so I know that I want to get everything to the same side so I can solve by factoring. I'm going to subtract 4x and I'm going to add 12 to both sides so that I can get everything over to the left side, set it equal to 0. When I do that, I end up with an x squared minus 10x plus 21 equal to 0. Now I can solve by factoring. Numbers that multiply to positive 21 that add to negative 10 are negative 7 and negative 3. I can set them equal to 0, so I can end up solving and getting an x equals. I ended up getting x equals 7 and x equals 3. Whew, that was a lot of work. You might need to replay that one more time. Go back through over again to make sure that you understand all of those different steps. Now, be careful. We also want to make sure that those numbers work in our original problem. So what I'd like you to do is I'd like you to pause the video. I would like you to go back to the original equation, and I would like you to substitute in a 7 for all the x's and see if the left side still equals the right side. Then I would like you to plug in a 3 to both x's and see if the left side equals the right side. I did that, and they both worked. So I know that both solutions will work, and I don't have any extraneous solutions. I know that x equals 7 and x equals 3.